This video is part 1 of Unit 3, Lesson 5, Derivatives of Inverse Trig Functions. So what we're going to do is we're going to take our knowledge of trig functions, and this is adding on to our knowledge of inverse functions, and we're going to find the derivatives of the 6 trig functions and use those in some practice problems. So we want to start out by thinking about the way the inverse function is related to the trig function in terms of a right triangle, which we have right here. Now we're going to go ahead and we're going to derive the 3 main ones, which are sine, cosine, and tangent, those inverses. And then on the next page, we will just be listing them, and that's another set of derivatives that you will have to remember. The reason why we're going to derive them is because they're not intuitive. Like, it makes sense that the derivative of sine would be cosine, but why is the derivative of tangent 1 over 1 plus x squared? I'm sorry, the derivative of inverse tangent 1 over 1 plus x squared. So where does that come from? And it comes from the right triangle relationship. So let's start with inverse sine of x and find the derivative of inverse sine. So the way we're going to start this is we are going to solve this for x, so it's going to be x is no longer, x is going to be a function of y. So it's going to look like this. So if y equals sine inverse x, then sine of y is going to equal x. So if we take the derivative of this function, because we know how to find the derivative of a sine function, not an inverse sine, we are going to get these values. We're going to take the derivative of sine, which is cosine y, and then of course we're going to have to use the chain rule because we have an implicit differentiation here, which is y prime, and that's going to equal 1. Solving this for y prime, we're going to have y prime is going to equal 1 over cosine of y. Now what do we do with that? So let's go to our triangle here, and we can see that cosine of y is going to be adjacent over the hypotenuse. So in this case, here's the angle y. The adjacent side is going to be the square root of 1 plus x squared. And the hypotenuse is 1. So our derivative then becomes 1 over that, or the reciprocal of that. So dy dx is going to equal 1 over the square root of 1 plus x squared. I'm sorry, 1 minus x squared. Okay, I wrote a plus there as well. This is just shit. I'm going to start over here. Okay, so the first one we're going to do is inverse sine of x. So let's start by rewriting this in terms of something that we can take the derivative of. So we'll rewrite this as sine of y equals x. And now we know how to take the derivative of both sides. So taking the derivative of both sides is going to give us, so sine of y is going to be cosine y, and then since this is an implicit differentiation, we're going to have our dy dx, and the derivative of x is 1. So solving for dy dx, we're going to get 1 over cosine of y. So we want our derivative to be in terms of x, though. So how do we go about fixing that? What we want to do is go over to our triangle, and if we have an angle y and a side x, the 3 sides of the triangle are going to be as shown. So cosine of y is the adjacent side divided by the hypotenuse. So in this case, it's the square root of 1 minus x squared over 1. So for our derivative, dy dx is going to equal 1 over that radical, so 1 over the square root of 1 minus x squared. So that's our derivative of the inverse sine of x. And we're going to use the same procedure for the other two as well. Okay, so now doing cosine, we're going to start the same way. So we're going to start by rewriting the inverse as a regular cosine function. So we're going to have cosine of y equals x. So now we know how to take the derivative of both sides with respect to x, which we are going to do. And we're going to have to use our implicit differentiation chain rule. So the derivative of cosine is minus sine, so we'll have a minus sine y. And then, of course, we need the derivative of y, which will be dy dx. And that's going to equal the derivative of x, which is 1. So again, solving for dy dx, we now have negative 1 over sine y. And again, going to our drawing, here's our y. Our triangle is just reoriented here. And so we have sine of y is now opposite over hypotenuse. So that's going to equal the square root of 1 minus x squared over 1. So our official derivative of the inverse cosine is going to be negative 1 over the square root of 1 minus x squared. And then finally our tangent derivative, starting out the same way. So instead of having y equal the inverse tangent of x, which we do not know how to take the derivative of, we do know how to take the derivative of tangent y equal to x. So we'll take the derivative with respect to x of both sides. And we get the derivative of tangent is secant squared y, and then again we need a dy dx with our implicit differentiation, and the other side of the equation will be 1. So solving for dy dx, we get 1 over secant squared of y. So again, secant of y is going to be hypotenuse over adjacent. So that is the square root of 1 plus x squared over 1. But we want to square this because we want secant squared. So we get 1 plus x squared. So our official derivative of the inverse tangent will be 1 over 1 plus x squared. So that's where those come from. So instead of just saying, okay, here are the derivatives, and you looking at them and going, why are they square roots? What happened to the trig functions? Now you understand it comes from the right triangle relationships they have. Now the ones listed here, if you notice, we have to assume that it is possible for the trig functions to have an inside function. So that's why we use u, and you may have to use the chain rule on that. But this is another set of derivatives that you are going to have to memorize. If not, you're going to have to sit down on the test and do exactly what we did here. And time is of the essence, so I would recommend you memorize these, just like the log and exponential derivatives from lesson 4. Okay, so let's do some practice problems with these derivatives. Now, if you notice, these will require the chain rule that we do have u's here. So like in part A, our u is going to be 5x. So what we can do is kind of sketch that off to the side to help us get started. So in other words, what I'm saying is when we recognize we are going to have a chain rule here, it might be helpful to say, okay, u is 5x, so u prime is going to be 5. So that then we can go right to this definition here The first one is arc sine, which is the same as inverse sine. So we can see right here that we can put our u prime on top and put our u in the denominator. Okay, so let's go ahead and do that then. So y prime is going to equal our u prime, which is 5, over the square root of 1 minus u squared. So 5x squared. So simplifying, we get y prime equals 5 over the square root of 1 minus 25x squared. Okay, same thing with letter B. So we are going to let u equal, and I'm going to write it this way, 2x plus 1 to the 1/2 power. So u prime, and again we have a chain rule in a chain rule. So we're going to have 1/2 times 2x plus 1 to the negative 1/2, and then times the derivative of 2x plus 1, which will be 2. So u prime becomes just 1 over the square root of 2x plus 1. Okay, so now our derivative for inverse tangent is going to be u prime, which is going to be 1 over the square root of 2x plus 1, and that's over 1 plus u squared. So u squared is going to be this squared, so it's just going to be 2x plus 1. Because if I'm squaring the square root, I'm going to get that. Okay. So then simplifying this, we're going to have y prime equals 1 over, simplifying the denominator, we get 2x plus 2, and that's going to be multiplied times our square root of 2x plus 1. Now, if you want to factor out a 2 and put that in front, you can do that, but this is an appropriate answer for this question. Okay, so you guys try the next 4, and I will put the answers here, and if you have any questions, we can go over them in class. Okay, so here are the answers to C through F, and as always, if you didn't get these answers, you can ask in class, and we can do them in class together. I want to point out here that in letter D, this answer would be acceptable, but if you want to simplify it, you could factor out that absolute value of x, since you have an x squared in each term of the square root. But leaving it in the one that's circled is perfectly fine for the AP test.